Okay, so we've talked about seafloor spreading now, and um, one of the things is we need evidence for this process. Because if I were to send you to the middle of the Atlantic Ocean and send you down in a submersible so that you could go see one of these underwater volcanic mountains, you in fact would not see the seafloor spreading. You would not see the motion. I mean, because it happens so slowly, your eyes can't detect it, even if you were to stay down there for a year, which would be impossible. So how do they know that this is really happening? The first category of evidence is simply the fact that there are eruptions down there. There is molten material. There are volcanoes. And rocks show molten material has erupted again and again along the mid-ocean ridge. If there were no eruptions, then there would be no new seafloor. And then we couldn't say that seafloor spreading is actually happening. So we also have this thing referred to as magnetic stripes in the rock. And this is a pretty complicated piece of evidence, but we're going to simplify it so that everyone in the classroom is going to understand how magnetic stripes in the rocks occur. And so we're going to take some notes on it, and some of these things may not make complete sense, but eventually they will. So we have first, magnetic reversals are recorded in the seafloor. So what do I mean by that? Don't look for this page. This is not in your notes. But it's important to realize that the Earth has a magnetic field. And so in this particular picture, they put what looks to be like a bar magnet through the center of the Earth. And so our Earth generates this magnetic field, and you can see that at this particular spot, in this picture, the magnetic North Pole is here, and the magnetic South Pole is here. Well, it turns out we have found in the rocks that this isn't always the case. We've had periods of times where the complete opposite is true. And magnetic north is there, and magnetic south is down there. So we have this indication that our magnetic field has reversed itself through history. And so we're going to pause just a minute and just generally talk about magnets and how compasses work. And so what happens is that the iron in the lava, there is iron in the lava, and what you know about iron, iron can be magnetized. If you were when you were younger, I don't know if you guys had this when you were little, but there was that toy that had this bald guy, and it had little iron particles in it, and then you had a little red magnetic pen, and you would drag the iron and you would give him hair or eyebrows or a mustache or a beard. And that little game worked because iron is attracted to a magnet. So iron in the lava lines up in whatever the direction of the Earth's magnetic field is like at that time. And then when it cools and hardens, it's stuck facing that direction, and that's a magnetic memory. And we've seen stripes, in other words, where the magnetic memory is going in different directions. And we see, and if you look at this picture, and again, we're going to do a demonstration for this in just a minute. If you look at this picture, you'll notice that this side of the ridge over here, those stripes that they put in here completely mirror the ones on the other side. So we're going to take a minute and we're going to make sure that we really understand what this means about magnetic stripes in the rocks and how they're evidence that seafloor spreading is happening. And the last category of evidence, the age of the rocks, we've talked about this when we did our demonstration, that the older rocks are farther away from the mid-ocean ridge and the younger rocks are closer to the mid-ocean ridge. And if you recall in our demonstration, we did see that that was the fact. And if all of the seafloor had been created at the exact same time, all the seafloor should be the same age. But instead, that's not the case. Where seafloor is being produced at the mid-ocean ridges, it is youngest. And where it spreads out, it's older. So again, just to review, the three categories of evidence to support seafloor spreading are eruptions of molten material, magnetic stripes in the rocks, and the age of the rocks.